What is the discharge temperature sensor for? And why is it important? Let's begin by saying that, with the widespread use of inverter-type air conditioning systems, and the constant search for more efficient equipment, precise control of all variables in the refrigeration cycle has become essential. One of these critical variables is the compressor discharge temperature, and to monitor it, we use the discharge temperature sensor. This sensor is located on the discharge or outlet pipe of the gas, right after the compression process. Let's recall that the refrigerant, after leaving the evaporator, the coil in the indoor unit, enters the compressor as a gas. Inside, it receives mechanical energy, which raises both its pressure and temperature. This post-compression temperature is the highest in the entire refrigeration circuit, and is especially important because it occurs inside the compressor, where the lubricating oil also circulates. If this temperature exceeds certain limits, it can reduce the viscosity of the oil, impair lubrication, accelerate internal wear, and eventually cause severe damage. Moreover, modern refrigerants like R32, due to their thermodynamic properties, exhibit a significantly higher discharge temperature compared to other gases such as R410A. In such cases, monitoring this variable becomes even more critical. Why does the discharge temperature at the compressor outlet rise abnormally? A high discharge temperature is due to abnormal operating conditions. Let's now look at the specific causes. 1. A small refrigerant leak reduces the amount of gas circulating. As a result, the gas coming from the evaporator reaches the compressor hotter, increasing the discharge temperature. 2. When the indoor thermal load is high, the refrigerant becomes more superheated in the evaporator. The gas entering the compressor is hotter, leading to a higher discharge temperature. 3. In high outdoor ambient temperatures, the condenser cannot dissipate heat properly. This raises the system's working pressure, increasing the compressor's workload and temperature. 4. With a dirty condenser or a faulty fan, heat dissipation decreases. This raises the high side pressure, making the compressor work harder, and increases discharge temperature. 5. If the expansion valve is misadjusted or defective, refrigerant feeding becomes insufficient. The evaporator doesn't fill completely, sending more superheated vapor to the compressor, raising the discharge temperature. 6. A blockage in the liquid line or in the filter dryer prevents proper refrigerant flow. The compressor operates against high pressure, increasing the discharge temperature. What happens if the discharge temperature is not controlled? In short, high discharge temperature should never be ignored. It is a clear sign of a system malfunction that, if not corrected in time, can severely reduce the compressor's lifespan and compromise the overall system performance. The discharge temperature sensor allows the electronic controller to make automatic decisions, such as activating thermal protections, reducing compressor frequency in inverter systems, shutting down the system to prevent serious damage. When is an error code generated? When the discharge sensor detects an out-of-range temperature, or if the sensor itself fails, open circuit or short circuit, the unit will display an error code. These codes vary depending on the brand and model of the electronic control board. How to test the compressor discharge temperature sensor. 1. With the unit off, locate the sensor on the thin compressor discharge pipe. 2. Disconnect the sensor from the outdoor control board. 3. Set a multimeter to the kiloohm scale. Connect the meter probes in any order and measure the electrical resistance of the sensor. 4. The multimeter reading should never be 0 or infinite. If it is, replace the discharge temperature sensor. 5. If you have the resistance versus temperature chart of the sensor, compare the multimeter reading with the corresponding value from the chart.